Hello guys, welcome back again to my channel guys. Before to study a new chapter, we are in chapter 2 and section 1. Chapter 1 it was the just introduction and of the physics. We studied the important one and we finished all chapter 1. Now chapter 2 section 1, new chapter. Phase of matter and force among the molecules. Guys, before guys to start to study this page, guys, this page is about the phase of the matter. I classify the phase of the matter. Liquid, gas, solid. Before this, I would like you to show you or to explain the different property between solid and liquid and gas. It is really important to know. Guys, let me explain in here slow for you like the difference between of them. Guys, look, first property that we have, actually we have solid and liquid and gas. First property of solid is, guys, this property is not in the book, but you have to know because important. First property, solid has a definite shape. Has a definite shape. The shape of the solid is clear, and the shape of the solid it isn't like changed. And even volume too, same thing. The volume and the shape of the solid it's clear. For example, you have this object. Look, the shape of the object of this object is clear, and even the volume too. We can't find the volume of this, and it's clear by the rule. And the shape is clear too. It's definite. The second property of the solid. Is guys, we have two molecules. Guys, we have two molecules in solid, 1 and 2. Guys, look, these two molecules, they are so close to each other. Guys, look at it. The distance between the molecules so close. So the second property of the solid, the distance between these molecules, it's so close. Distance between this molecules so close. The third property, we have a force between the molecule. Is the force large or small? Guys, pick the rule, because the distance between these two molecules is so close, so that means we have very large force. Why? Because the distance between molecules is small and we have very large force between the molecules. And the last property, incompressible or cannot compressible. Cannot compress it or compressible. Guys, a solid property, we cannot make a pressure. Compress means pressure. We cannot make a pressure on the solid matter because, guys, the reason is the distance between the molecule is so small. There is no way we cannot even apply the force, or we cannot even apply force or pressure on it. So first, the shape is clear, and the second one, the distance between the molecule is small. Because this distance is small, we have a very large force, and the last one, we cannot make a pressure because the distance is small. This is about the property of solid. What about property of the liquid? Property of the liquid. Liquid property. First, liquid property, their shape it's not definite. It's not definite, but their volume is definite, or it's definite. Yes, definite. So, guys, you know the best example. So the liquid has no definite shape. The shape of the liquid all time will be changed half. Right. So for example, you have waters in two different containers. For example, you have waters inside this glass, or you have water inside the bottles. We have water inside this bottle. Look, and same volume, 2 milliliters and still 2 milliliters. So both of them it's water, but inside two different containers. So that's why the shape of the liquid will be changed. Same, like both of them is water, but inside different shape container. So the waters of the liquids take the shape of the container. So the shape it will be changed to, or for example, the same water inside the plastic or glass or bottle. So look, the shape it will be changed. So that's why, guys. So so even have same volume. The third property we have, the third property is the force between the molecules. The force between the molecules. But before to tell the force, guys, the distance between the molecule of the liquid is small. Yes, but compared to the solid, it's large. Look, this is the distance between the distance between the molecules, and look the distance between the molecules of the solid. So it's small, but it's small too. But compared to the solid, we have a little distance, large. So the distance between the molecules, it's more than the solid, and that's why the force between the molecules of the liquid, the force between the molecules. So this was the first property and the second property. The force between molecules, it's small compared to the solid because the distance is large. I said if the distance is large, we have a small force, but the distance is small, have a large force. Okay, guys. The third property, as I said, the third property is certain. The distance between the molecules, it's we have distance, but compared to the solid, it's large. The liquid. The last property, guys, the last property of the liquid, we can compress. Guys, not like most of the time we can compress. We can compress in a small extent. Compress it, but in a small extent. It means sometimes we can make a pressure and sometimes not, because the distance it's still small, but compared to solid it's large. That's why. Okay, guys. So the first property, it was not different shape but different volume, and the second property, their distance is small and we can compress small extent. And guys, one thing it's left, the type of the force. The type of the force, it's small. We have small force attraction. The small force attraction. Again, why we have small force attraction? Small force, because the reason is again the distance between them. We have now large distance, as I said, compared to the solid. That's why we have a small force. But the solid, there is no distance but large force. Okay, guys. Now the last phase of matter. The last phase of matter is a gas. Guys, the gas. Look, gas. The first property of gas, not different shape and not different volume. Both state, look, both will be changed. Even the shape or volume. So shape and volume both will be changed. The shape and the volume both are gonna be changed in gas. For example, guys, we have a gas, or the oxygen. We can breathe oxygen, right? Could you see the oxygen O2 by your eyes? No. Could you determine the shape? No. Could you see the volume? No. So even this is gas. So that's why the gas, you cannot even determine the shape and the volume. The second property, Guys, the distance between the molecule of gas is so large. So the distance is large. Distance to the molecule is so large. So the third property, that's why there is a weak force. There is a weak force because the distance is large. I told you, if small distance, large force. If the large distance, weak force. The last property, guys, we can easily compress. We can easily make a pressure or compressed. Again, why? Because the reason, just again the distance, guys. If there is a small, if there's a large distance, we have a weak force, we can easily make a pressure. So guys, this is in general the different property between of them. I hope to get the benefit from the properties. Really important, guys. The property of the liquid and gas and solid, because in the upcoming section, really, you have to understand again, because you will study inshallah. Okay, guys, now phase of the matter and the molecules. Guys, now as I told you, we have three phases of matter: solid and liquid and gas. We said solid is a definite shape and volume. At this time it's small. We have a large force. We studied all. We showed you all the type of the property. Guys, we have a last phase of matter. It's called plasma. Guys, plasma is still a phase of the matter achieved a very high temperature. So plasma all time is gonna be happen at very high temperature. For example, fire or star. In the book, it's written star because star structure, it will be happen just very high temperature. Or the universe. Look at most of the mass universe is concentrated in the stars. So stars. Its phase of the last phase is a plasma. Hey guys, so the definition phase, one of the phase four state of the matter, it's solid and liquid and gas plasma. So we have four phase state of matter: solid, liquid, gas, or plasma. Guys, we have some questions. Guys, look. We understand now plasma is going to be happen very high temperature, but I want to know what is the structure of the plasma, or plasma consists of what, or what is the composition of plasma. Guys, plasma, look, because the question is by blue, even the answer by the same color to do not mix it. Plasma, it consists of the atom nuclei. So first the structure is atom nuclei and electron. They are moving at very high temperature. So the structure of the plasma is atom nuclei and the electron, they are moving at very high speed. We have another question, guys. We have another question. Sorry, another question we have. This is, wait a minute. This is wrong. It's yeah. Can matter exist? Look. Can matter. Let me erase this. Leave it yellow. Can matter exist in three phases? Guys, this question it means. We have solid and liquid and gas. Can matter exist? Can one matter, for example, one example is exist in both all of the three phases, solid, liquid, gas? Yes. Guys, let me tell you. For example, this is the answer. Many materials, many exist in three phases. For example, ice, guys. Look, we have an ice. Let me tell you here, Baba. Look, we have a small object. This is ice. How we make this ice to waters? Of course, give them energy, heat. Heat this object. It's gonna be water, right? It should be a water after give them thermal energy. It's gonna be melting. Look, ice, for example, can melt to form water. Yani when you give them a heat to this ice, it's gonna be water melting. Still give them energy, heat. The waters would be boiled and become water vapor. It's gonna be gas. First, it's ice. Give them heat. It's gonna be water. Still give them energy. More is gonna be gas. So from the ice, it will be melting. It became water. For the water, it's gonna be boiling. It's gonna be water vapor. So of course, now can matter exist in three phases. For example, ice from solid, it will be liquid, then liquid to gas. Ice, water, then water vapor or gas. Another example, another question: can matter be transformed from one phase to another? Of course not. I told you by this example, guys. We can change the state of the matter from one phase to another by give them what? by give them an energy. But which type of energy? By give them mechanical or thermal energy. Guys, this is important. First, mechanical and thermal energy, heat. By give them heat, thermal energy. Now, as I showed you in here, by give them a heat or thermal energy, the state of the matter from the solid to gas will be changed. Or sometimes by the mechanical too. By the mechanical, you can convert the state of the matter. Guys, in here we have another thing interesting. This is done by changing their pressure and temperature. Guys, of course, look, when you want to make from the solid state to the, for example, to the water, or from solid to liquid, solid have a different pressure. When you want to make it to liquid, even the pressure will be changed to, even the temperature too. So solid, as I told you, solid have a different pressure, and the liquid and gas too. So when you want to change the state of the matter, the pressure of course will be changed. So that's why it's written, this is done by changing the pressure and temperature. During when you want to change the state of the matter, the temperature and the pressure still it will be changed. So guys, in here I highlight this. We have 3 questions. You can highlight it. We said plasmas consist atom and nuclei, and matter exists in 3 phases. Yes, for example, the eyes by give them heat. Can matter transfer from one phase to another by give them thermal energy or mechanical energy. Guys, we have another. Now we already finished the first part of the topic. Classify the matter. We classified. Now the second part, it's left. Difference between the force attraction and repulsion among the particle of the matter. Guys, between the molecules, between the matter, we have some type of the force. Guys, actually in this page it's explained by the complicated way. I summarize all by three ways. Understand and enough. Like, understand this 3 rules is enough. I summarized this topic. Guys, look, Baba, between the molecules, there is a type of the force. Sometimes it's attraction, sometimes it's a repulsion, sometimes there is no force. How we know, guys? Look, between these 2 molecules, the distance between these molecules, it's called R0, or it's called equilibrium distance. Equilibrium. Oh my god, this my spelling is wrong. Let me wait. Equilibrium distance, the distance between the molecules. The distance between the molecules is called equilibrium distance, guys. Or I told my students to understand easily, I told them this R0 is the original length, or the real distance between the molecule, guys. So we have another distance between the molecules, guys. Look in here. For example, this distance is 3, for example, and this equilibrium distance, for example, is 2. How we know the type of the force? It's attraction or repulsion, or there is no force, guys. In example, when the questions give you the last distance, compare this distance with the original one. If this distance, it's they have a large distance, for example, in here we have 3. This distance is compared to the original one is greatest one, because it is bigger than this distance R is greater than the equilibrium distance. This R is greater than the R0. Right? If it's like that, it's greater. So the type of the force is attraction. The type of the force is attraction. So if the distance it's greater than the original one, is attraction force. What if the distance, same example, if the distance between the molecules, for example, the R it's 1. In here we have this distance between the molecules, it's 1, but the original one it was 2. Now this R it's smaller than R0. In that case, the type of the force is repulsion. So Baba, if the distance compared to the original one is, if it's greater distance, the type is attraction. If it's smaller distance, the type is repulsion. What if we have same distance, both of them? For example, look guys, same distance again. In here, distance is still is equal to 2. The original is 2. Yeah, and both of distance is equal to. So because the distance are are same, that means in that case there is no force. So this state is called equilibrium state. Guys, in general, if the distance between the molecules, like if the distance that I'm going to give you an example, compared to the original one, if it's the greatest values, the type of the force attraction. If it's they have a less value compared to the original one, like in that case, look, it's repulsion. If it's equal, so equilibrium state. Guys, look, even here I make a question. When does the two atoms are in state equilibrium, when the distance equal? Look, if it's same distance, equilibrium state. When does the force between the two atoms become attraction? When the distance become large to the original one. When does the force between the two atoms become repulsion? When the distance is smaller than the original value. So guys, easy. I summarized by the three rule. Guys, we have some parameter in here. Is written molar mass, m capital, m small, and molar volume. This one in the upcoming chapter, upcoming section, I'm going to explain more. We study the type of the force, guys. In general, we have a last part of a topic. It's called bond. Guys, between the molecules, of course, the molecules are combined by the bonds. For guys, I'll look at that picture. This is positive and negative charge. Look, and this is positive and the negative charge is combined by the bond. And this type here, ionic bond, yes, but it's combined by the bond, of course. Between a negative and positive charge, you have a bond. Negative and positive charge, you have a bond. Look, by the bond, they are combined together. Bond, always bond. So by the bonds, they are combined, guys, and the negative and positive charge. Look, a bond. What is the definition of bond? A force is linked to the interactions among the atoms of an element due to the mutual interaction. Guys, in general, bond, for example, you have these molecules and two molecules. This molecule, they are combined by this bond. This is called a bond between the molecules. So this atom is positive charge, the other one is negative charge. So the bonds, they can lead two objects to attract to each other and to combine together. This is just bond definition. We have three types. Guys, of bond. The first type, it's called ionic bonding. The first type is called ionic bonding. Guys, the definition I wrote by myself is not in the book. Ionic bonding, guys. What is ionic bond? The first type, a chemical bonds formed between two ions with opposite charge. Ionic bonds formed when an atom gives up or one or more electron to another gain. Guys, we know the bond is between two opposite charge. Of course, one of them is negative, the other is positive. Now in here I showed you, look, negative and positive. But what is that ionic bond? Guys, look, we have in here, we have example Na atom and we have Cl atom. Guys, around this atom, of course, you have electron. You have to know electrons around the sodium, and Cl2 you have electrons. Guys, look, this sodium, they would like to kick this electron out of the atom. They would like to kick electron out of them. They would like to throw this electron. When this process happens directly, this chlorine, this Cl, immediately when the electrons kicks out, now look, the electrons goes out of the sodium's atoms. The Cls, immediately they took this electron to their atoms. These Cls, they like to receive these electrons. After that, when this process happens, the Na is become a positive and the Cl is going to be negative. Then at the ends, the bonds is between Na and Cl is formed. So this bond is called ionic bond. So guys, first, the atom, they took this electron out of the atom. Sodium, they took the electron out of the atom, they kick out. Immediately, the chlorines, they took this electron, they received these electrons. This process happened, the Na is going to be positive, the Cl is going to be negative. So the bond between the atoms, it will be formed between the NaCl. Okay guys, look, the definition, now I said all. Look, however, needs one electron for this, the chlorine atom. Guys, look. Okay. The chlorine atom, this chlorine atom, atoms have a needs one electron. Look, for a third shell to become completely full electron. This Cl, they need to take electrons, full of the electrons, becomes atom preferred at complete shell. The sodium atoms tend to give away its single electron to the chlorine atom. This sodium, they need to give away to take out this electron to the of the atoms of this shell. The sodium they want to take out, to throw out, to kick out this electron, this sodium atoms. The sodium atoms become positive. Look, it's become a positive, while the chlorine atoms it become the chlorine atom it become what? It's become a positive. Sorry, the chlorine become a negative. Look, become a negative. Then the last one, a strong bond exists between them. The strong bond exists between them. In general, sodiums kick out electron, the Cl receive the electron, Na become positive, Cl become a negative, and the bond is formed, or bond is exists between Na and Cl. So this is called ionic bonding, guys. The second type that you have, it's called covalent bond. Guys, covalent bond, look, when an atoms are unable to gain electron, this is not like the ionic bonding, guys. This type of the covalent, they don't have ability, they cannot to gain or lose electrons to completely partly fill their shell. They don't have ability to take or out or the receive electron. So otherwise, what they were gonna do, they can just share electron as a bond between the electron. So how? Look at that picture, guys. This is the first atom, and this one is the first atom. This is the second atom. By sharing electron, look, both of them, this is electron, they are shared this electron among them, among these atoms, among this atom, they are sharing electrons. So by this electron they can form a bond. So this electron is like a bond between these two atoms. So covalent bonds, they can just share electron, but ionic bonds, they can ionic bond, they are receiving electron or gaining electron. I hope it's clear, guys, to understand. The last part, the last bond, it's written metallic bonding. Guys, metallic bonding is not that much important, but even I'm gonna explain for you, no worry. Guys, metallic bonding, look, in metallic bonding, the atoms lose their innermost electrons, which move freely inside the metal. The electrons, they are moved in randomly direction. The electrons, they are moving in random direction. They are moving freely. And the metal atoms, they become positive. So the electrons, they are moving freely. Look, a free negative electron, they are moving among atoms. The electron, they are moving, and the other metal atoms become a positive charge. So this is called a metallic bonding. Guys, from this lesson, I'm done. It's enough. For the upcoming chapter, upcoming session, inshallah, we'll be continue to take the video of grade 10 physics, inshallah, guys. If there's any question, if there's any comment, you can write down for me. I'm gonna answer you. If there's any question, thank you for subscribing my channels. Thank you for all. Have a nice day.